This is an example of a complex fraction because there are fractions within the fraction. And usually what we want to do here is simplify it so that we end up with a single fraction answer if possible. One thing we have to remember here is that there are actually parentheses in this problem that are implied. There's parentheses around the numerator and parentheses around the denominator. In order of operations, say we always do what's within parentheses first before we do other operations, which includes the division, which is actually right here in the middle. Okay, so we need to do the subtract problem on the top and the addition problem on the bottom. So to do that, we need to have a common denominator. The common denominator between 2 and 3 is, of course, 6. So we're going to multiply the first fraction by a 3 on the top and the bottom, and the second one by a 2. And that'll give us 3 minus 8, which gives us a numerator of negative 5/6. Okay? Now in the denominator, our common denominator is going to be 4. So I'm going to multiply the first fraction by 4 on the top and the bottom. And of course you could do this in your head if you needed to. So we're going to end up with 4 plus 1, which is 5/4. So we have 5/4 here. Okay, so this problem really stands for negative 5/6 divided by 5/4. That's what that means. What we're going to do to finish this problem, we'll leave our numerator alone, negative 5/6, and then we're going to multiply by the reciprocal of the denominator, which would be 4/5. Now, if we multiply across here, we would end up with negative 20/30, which of course reduces down, and we certainly can cancel out common factors here, divide out a 5 out of the top and the bottom, and a 2 out of the top and the bottom, to get our final answer, which is going to be negative 2/3. So did we go from a complex fraction to a simplified one? Yes. Now I'd like to quick show you an alternate method, and this is actually the method that I prefer to teach in my pre-calculus class, although I do show it in Algebra 2 as well. This idea sort of assumes that you understand the concept that multiplying a fraction by 1 does not change its quantity, and we've known that for a long time. It also assumes that you remember that you can multiply a fraction. When you multiply a fraction by 1, it can be any fraction that has the same thing on the top and the bottom. It could have an x on the top and the bottom, it could have an a, it could have an x squared, it could have a number, it could be anything. So what we want to actually do here is multiply the top and the bottom of this fraction by the lowest common denominator between 2, 3, 1, and 4. So the lowest common denominator between 2, 3, and 4, 1 and 4 is actually 12. So I'm going to multiply this fraction by 12 on the top and the bottom, which essentially is like multiplying it by 1. Okay, now I need to do the distributive property. I'm going to multiply this 12 into both parts. And here's how the problem will look. I will have, my original problem said 1/2 minus 4/3 divided by 1 plus 1/4. And I'm going to multiply each part of the fraction by 12. Okay. Now, when you're multiplying a fraction by a whole number, of course that 12 is really over 1. So we're really multiplying the 12 by the numerator part of each fraction. So we're going to end up with 12 times 1/2 is 6. 4 times 12 is 48, divided by 3 is 16. 12 times 1 is 12, and 1/4 of 12 is 3. When we add those together, or when we combine the numerator, we get negative 10 over 15, which is going to reduce down. I can divide a 5 out of the top and the bottom, which is going to make negative 2/3. Did we get the same answer as what we got before? Yes. Both methods are are good methods. I tend to use the second one more often. Now let's apply this to a harder problem. Okay, this one is an algebra expression. What I'd like to do here is sort of analyze the problem first to determine what its parts are. Really, I'm looking for the lowest common denominator. I'm going to use the second method. So I get 1/4 minus 2 divided by, I'm going to factor a 5 out so that I have x minus 3. I'm going to divide that by 1 over, and I'm going to factor x out so I have x minus 3. Now if I look at each part of my denominator, I have a 4, I have a 5, I have an x minus 3, and I have an x, and then I have another x minus 3. Okay, so my common denominator is going to be 20x times the quantity x minus 3. And I'm going to multiply my entire fraction by 20x times the quantity x minus 3 on the top and the bottom. Okay, so I'm going to multiply the whole thing. And remember, I'm going to have to do the distributive property on the top. Okay, so here's what my problem is going to look like. Let me just quick write this down again. Okay, so again, remember that this is going to go to the top part of the problem. 20x times x minus 3, 20x times x minus 3, and 20x times x minus 3. Okay. All right. Now let's cancel out any common factors. 4 goes into 20 5 times, and nothing cancels out. So that part of the numerator is going to be 5x times the quantity x minus 3. And in the second part, an x minus 3 will cancel out, and a 5 will cancel out of the 20 and leave 4. So we're going to have 2 times 4 times x, or 8x. In the denominator, I'm going to cancel out an x minus 3, and I'm going to cancel out an x, which is going to leave me with 20. That's kind of nice. So I need to simplify the numerator. I end up with 5x squared minus 15x minus 8x over 20. I'm almost done. Which leaves us with 5x squared minus 23x divided by 20. Now, you certainly can leave your answer like this if you want. X times the quantity 5x minus 23 divided by 20. Either one is okay. And that's it.